Welcome to Learn Maths TV. Let's look at this problem. We have root 12 all over root 15 plus root 3 all raised to power 12. Looking at this maths, it looks a little complex, but don't worry. Following our step-by-step method, we are going to profess solution to this. So how are we going to start? Of course, we're looking for this. Let's begin by saying solution. All right, we have root 12. We all know that root 12 is the same thing as root 2 times root 2 times root 3. Somebody is asking, how did we get this? Now look at it. If we have 12, and of course I'm dividing, I will have 2 divided by 12 will give us 6, 2 divided by 6 will give us 3, and 3 here is 1. So these are the factors of 12. So we have 2, 2, and 3. So root 2 times root 2 times root 3 is the same thing as root 12. So if this is the same thing as root 12, it means that I can replace this for root 12. As such, I'll be having root 2 times root 2 times root 3 all over. We have root 15. Of course, our 15 is also the same thing as root 3 times root 5. And 3 dividing 15 is going to give us 5. 5 divided by 5 right, that's going to give us 1. So root 3 times root 5 is giving us root 15. So this is what we're going to have. So I will substitute this for root 15, and I'll be having root 3 times root 5 plus root 3 all raised to power 12. Now, if this is true, it then means that root 2 times root 2 is root 4 times root 3 all over root 3 times root 5. We'll be having root 3. Let me use dot to replace the multiplication sign. So I'll be having something like this plus root 3. Now, what is the square root of 4? The square root of 4 is 2, so we'll be having 2 root 3. The square root of 4 is 2, then we're having now root 3. All over, we have root 3 times root 5 plus root 3. Let's take, for instance, we have AB plus A. Remember that A is common here. Of course, there's an addition here. So if this is true, if I pick my A, I'll be having here B plus 1. And they are the same. A times B will give us AB plus A times 1 will give us A. So if this is true, let's apply it here. We have root 3 and root 3 here. So if I remove my root 3, I'll be having here root 5 plus 1. Of course, root 3 times root 5 will give us the same thing here. And of course, root 3 times 1 will give us root 3. Remember, all these things are raised to power 12. They are all raised to power 12. If this is true, let's make use of this place. So permit me to wipe here. As such, I'll be having 2 root 3 all over root 3 into root 5 plus 1 all raised to power 12. Let me turn this way. So if I cancel root 3 and cancel root 3, that's accurate. And I'll be having 2 all over root 5 plus 1 all raised to power 12. I hope we are following. Don't worry, this math will later come to an end. Now, when we have something like this, we are going to rationalize. We have 2 all over root 5 plus 1. Because of the root 5 at the denominator side, we will rationalize. Remember our sodic function. Of course, this conjugate, we are going to rationalize, but the sign will change. As such, we'll be having 2 all over root 5 plus 1. This conjugate will be multiplied up and down. That means we'll be having root 5 minus 1 all over root 5 minus 1. That's how it occurs. If it is negative here, then it will be positive and positive. If it is positive, then in rationalizing, this will be negative and negative. Remember, all raised to power 12. So if we're multiplying here, 2 multiplied by root 5 will give us 2 root 5 minus 2 multiplied by 1 will give us 2 all over. So this will be multiplying this. Root 5 plus 1 will be multiplying root 5 minus 1. So permit me to solve it here. Then whatever we get, we replace it here. So what are we solving? We are solving root 5 plus 1 multiplied by root 5 minus 1. Watch me. We are going to use this one to multiply this. We are going to use this one also to multiply this. Then when we are done, we use this one to multiply this. We use the same one to multiply this. So root 5 times root 5 will give us root 25. Root 5 times minus 1 will give us root 5. Then plus 1 times root 5 will give us plus root 5. And plus 1 times minus 1 will give us minus 1. Now we have root 25 minus root 5 plus root 5 is 0. Just like we have minus 1 plus 1. Of course, it's 0. Now, so we cancel this and cancel this. So we'll be having minus 1. The square root of 25, of course, is 5 minus 1. So 5 minus 1 will give us 4. So it means that if this and this multiply itself by expansion, we get 4. So what will be here is 4. Remember, all raised to power 12. If this is true, then it means that this simply means 2 into root 5 minus 1 all over 4. Remember that 2 times root 5 will give us root 5, and 2 times minus 1 will give us minus 2, so they are the same. So I can cancel this to give me 1 and cancel this to give me 2. If that is true, what we are having now, remember, all raised to power 12, don't forget. So we're having root 5 minus 1 all over 2, all raised to power 12. Correct. So permit me to turn this way. We are gradually progressing. Good. It means that what we have now is, root 5. I hope you're seeing it. I hope I'm not crossing. Root 5 minus 1 all over 2, all raised to power 12. Now, in order to continue with this, let's say x is equal to root 5 minus 1 all over 2, which means anywhere we see the whole of this, we replace it by x. If that is true, it means that the entire of this thing is root 5 minus 1 over 2. Permit me to be this way. All raised to power 12. That's what we have here. It will be equal to, since the entirety of this is referred to as x, we now have x raised to power 12. This and this are not the same. It means that I can now cancel the power root 12 and root 12. As such, I'll be having root 5 minus 1 over 2 is equal to x. Of course, you know that your x is the same thing as x over 1. Any number is same thing as over 1. If I say 3 is same thing as over 1. If I say 4 is same thing as over 1. So if that is true, we can now cross multiply. S will multiply 2 and 1 will multiply the entire thing here. So we'll be having 2 times x, we have 2x is equal to 1 multiplying everything here is of course the same thing. So we have root 5 minus 1. Now if that is true, our minus 1 will be crossing this equal sign. As such, we'll be having 2x minus 1 crossing the equal sign will give us plus 1 is equal to the root of 5. Now, are we following? Good. If we are following, we will remove the square root here in 5. And how do we do that? By squaring the both sides. Both here and here will be squared. As such, if I square here and square here, I can now cancel the square and the root. So what will be remaining here will be 5. So it means that all I have here is 2x plus 1 all raised to power 2 is equal to 5. If this is true, then we can continue. So permit me to start here again. All right. The maths appear a little complex, but don't worry. By our step-by-step method, we end up solving this. So this is what you have here. Employing it here, it means that we have 2x plus 1 all raised to power 2 is equal to 5. So we are going to expand this. And if we expand this, what are we going to get? Let's say, permit me to wipe here. Permit me to wipe here. Okay, let's expand 2x plus 1 all raised to power 2. Of course, if you have 2x plus 1 all raised to power 2, it will mean 2x plus 1 multiplied by 2x plus 1. Good. In expansion, let's wipe this. We'll be having 2x times 2x, we'll be having 4x squared, plus 2x times 1, we'll be having 2x. 1 times 2x, we'll be having 2x. 1 times 1, we'll be having 1. As such, we'll be having 4x squared plus 4x plus 1. So this is what we obtained. Now, if we expand this, we definitely obtain 4x squared plus 4x plus 1 is equal to 5. Now, if this is true, it then means that our 5 will cross this equal sign so that here will be 0. As such, we'll be having 4x squared plus 4x plus 1. 5 crossing the equal sign will give us minus 5. And of course, here will be what? 0. So we'll be having 4x squared plus 1 minus 5. We'll be having minus 4 is equal to 0. Now, seeing this, what are we going to do? There is 4 here, there is 4 here, there is 4 here. So in order to reduce this equation, I will divide through by 4. And that's what I'll be having. Such that I can cancel 4 and cancel 4, cancel 4, cancel 4, cancel 4, cancel 4. Here will remain 1. Now I'll be having x squared plus x minus 1 is equal to 0. Wow! I finally arrived at a quadratic equation. We can do. Of course, we have x raised to power 2 plus x minus 1 is equal to 0. Permit me again to turn this way. So if this is true, then it means that our plus x and our minus x will cross the equal sign. And of course, if they cross the equal sign, we'll be having x squared plus x crossing the equal sign, we'll be having minus x, and minus 1 crosses the equal sign, we'll be having plus 1. This is exactly what we'll be having. Of course, minus x plus 1 is the same thing as 1 minus x. So which means that we are having x squared is equal to this. Look at it, minus x plus 1. Minus x plus 1 is anything as minus x, and of course this is 1. Just like where we have minus a plus 1. I can say 1 minus a. This is minus for a, this is minus for a, this is plus 1, this is plus 1. So that's exactly what I did here. And of course, this is what we are having. So if I will write it very well, it then means that I can call this my equation 1. All right, now that we have gotten our equation 1, what else are we going to do? Recall that we said x is equal to root 5 minus 1 all over 2. Of course, we extracted it from this. So if the entirety of this is x, of course, we are raising it to power 12, which means that if we said that, let me use this to cite it. If we say we had, of course, this to be root 5 minus 1 over 2 all raised to power 12. We now said here that let the entirety of this be x all raised to power 12. So which means that our target is what do we do so that we can be able to get it all x raised to power what? 12. If that is true, then what we're going to do, recall that in the law of exponents, if a is raised to power m and then raised to power n, that it means a raised to power m n. If that is true, now if we have x raised to power 12, I can say that x raised to power 12 can mean x raised to power 3. If I raise it to power 2, I'll have 3 times 2 is 6. It's not up to x raised to power 12. So if I raise it again to power 2, I can have 3 times 2, 6. 6 times 2, 12. So which means that if I can have my way to reduce whatever I'm doing through this, multiply it by, raise it to power 2 and raise it to another power 2, I can be able to arrive at the expression that will equal this. And if that is true, now let us see what to do. Permit me to wipe here, and with what I have just said, let's say that we have since we have x raised to power 2, let's say we decide to put it this way, multiply by x raised to power 1, that's this. If we decide to multiply x raised to power 1 to this at both sides, it means we'll be having 1 minus x multiplied by x raised to power 1. this equation 1 is what I brought down here. I just multiplied by x raised to power 1 and multiplied by x raised to power 1. Why did I do that? I want to arrive at that thing I did before, where we had x raised to power 3. We multiplied, we raised it to power 2, and again raised it to power 2. So that if 3 is multiplying 2, we are getting 6. Multiplying 2, we are getting 12, which is x raised to power 12, arriving at this. So if that is true, then I would say that this multiply this, of course, when they are common, the powers are added. Remember the law of exponent. So we have x raised to power 2 plus 1 will give us 3 is equal to x raised to power 1 is same thing as s. So x multiplying the whole of this will give us x minus x squared. But then recall, x squared is equal to 1 minus x, which means anywhere we see x squared, we substitute it for this, which means we'll be having s raised to power 3 is equal to x minus, what is our s squared? 1 minus s. So we'll be having 1 minus x. As such, our x raised to power 3 will be x minus, here is 1, of course it will affect here, minus times minus will give us plus x. And we'll be having our x raised to power 3 to be x plus s will give us 2x minus 1. Good. If that is true, permit me to cross to this side. Okay, I'm going to replicate this to this. It then means that if I decide to square both sides, then I will have x raised to power 3 all raised to power 2. I've succeeded squaring here. Then squaring this side, I will have 2x minus 1 all raised to power 2. As such, I'll be having x raised to power 3. 3 times 2 is 6. So I'll be having x raised to power 6. And of course, we will need to expand this. So if I expand this way, I'll be having 2x minus 1. Of course, we've done it before. 2x minus 1. By expansion, 2x times 2x, of course, will give us 4x squared. Then 2x times minus 1 will give us minus 2x. Minus 1 times 2x will give us minus 2x. Minus 1 times minus 1 will give us plus 1. Now, what we'll be having is 4x squared minus 4x plus 1. This is what we are going to obtain. So when we expand this, we definitely get this. So importing it here, what I will have is 4x squared minus 4x plus 1. Now, we succeeded to get x raised to power 6. Now, if that is true, remember that we said our x squared is equal to 1 minus x. So which means that anywhere we see our x squared, we substitute it with this. If that is true, then our x raised to power 6 will be equal to 4. What is our x squared? 1 minus x. So we'll be having 1 minus x. Of course, minus 4x plus 1. So we'll be having x raised to power 6 is equal to 4 times 1, we have 4, minus 4 times x, we have 4x. Of course, we're having here minus 4x plus 1. The maths look a little longer, but don't worry, we are arriving. Remember, we have here to be 1. So we have x raised to power 6 is equal to 4 minus 4s minus 4s is giving us minus 8x plus 1. Then x raised to power 6 will give us 4 plus 1 is 5. So we're having 5 minus 8x. Then I can also decide to square both sides. So squaring both sides, I'll be having like this and this like this. As x raised to power 6 raised to power 2 will give us x raised to power 12 is equal to, expanding this now, I'll be having 5 minus 8x multiplied by 5 minus 8x. And as such, I'll be having 5 times 5 is 25. 5 times minus 8x will give us minus 40x. Minus 8x times 5 will give us minus 40x. And minus 8x times minus 8x will give us plus 64x squared. So this is what we obtain. If I import it here, of course, I'll be having 25 minus 40x minus 40x plus 64x squared. Now, if this is true, remember that I said anywhere we see x squared, we should put it 1 minus x. It means that this 64x squared, this x squared will be substituted with 1 minus x. If that is true, then if I wipe here, We're having x raised to the power 12 is equal to 25 minus 40x minus 40x plus 64x squared. Remember that our x squared is to be replaced with 1 minus s. As such, we'll be having our x raised to the power 12 to be equal to 25. Of course, minus 40s will give us minus 80x plus 64x squared. Remember, I said that x squared is to be replaced with 1 minus x. So we'll be having that x raised to the power 12 will be equal to 25 minus 80x plus 64. Our x squared is 1 minus x. And as such, we'll be having that our x raised to the power 12 will be equal to 25 minus 80x plus 64 times 1 is 64, and plus 64 times s will give us minus 64x. If this is true, then we'll be having x raised to the power 12 is equal to 25 plus 64 will give us 89, and then we are having here minus 80x minus 64x. And of course, our x raised to the power 12 will be giving us 89 minus 80x minus 64x will give us minus 144x. But recall, while we were solving, you remember while we were solving that I said that x is equal to root 5 minus 1 all over 2. That was what we stated initially while we were solving. If this is true, then permit me to make use of this board. It then means that this, our equation, x raised to the power 12, which is equal to 89 minus 144x, will be, remember that our x is root 5 minus 1 all over 2. So our x raised to the power 12 will be, permit me to be this way, so I have 89 minus 144. What's our x? Root 5 minus 1, root 5 minus 1 all over 2. So that's what we're having. So if that is true, it then means that if I cancel 2 here, it will give me 1. If I cancel 14, it will give me 7, and cancel 4, it will give me 2. So I'll be having that x raised to the power 12 will be equal to 89 minus 72 into root 5 minus 1. As such, what will I be having? Our x raised to the power 12, our x raised to the power 12 will be equal to 89 minus 72 times root 5 will give us 72 root 5 minus, minus times minus is plus, so 72 times 1 will give us what? 72. So what we'll be having now is x raised to the power 12 is equal to 89 plus 72 will give us what? 161 minus 72 root 5. So if this is true about this, then it means that this, which is root 12 all over root 15 plus root 3, which is the equation, can be expressed as this, which is 161 minus 72 root 5. And this is the answer in its simplest form without using calculator. Wow, what a wonderful mathematics. I hope you enjoyed it. Please drop something on the comment section, and don't forget to like, to share, and to subscribe. We remain Learn Maths TV. Bye bye.